Okay. Yeah, good morning, everyone. Today, Beinan and I bring the topic Iceberg plus Alluxio for faster data analytics. Before we dive into the content, Beinan, do you mind to introduce yourself?
Hello, everyone. I'm Beinan from Alluxio. I'm the committer of PrestoDB, and also I got my PhD from Syracuse. Feel free to ping me via Slack and email.
Thanks, Beinan. This is Shouwei. I'm the co-maintainer at Alluxio. Before joining the Alluxio, I'm the PhD in Rockers, focused on the optimizing the performance for the large-scale distributed system. And currently, I'm more focused on the adoption, Alluxio adoption for the data lake, structured data, and also do a lot of community works. We welcome everyone to join our Slack channel and post any questions there. Today, we will go through 4 different topics here. First of all, we will go through the Alluxio overview, and then we will give some adoption solution, how you can run in the Iceberg with Alluxio. After that, Beinan will give the instruction for you to how to query your Iceberg table with Presto, and give some update on what is going on in the community for the Presto Iceberg connector. And we will have several minutes for the QA session. What is Alluxio? Alluxio is an open source project based on the Java language. And nowadays we already have more than 1,000 of the contributors. And yes, last year we also rated as the top 10 most critical Java-based open source project by Google. And we have more than 5,000 Slack community members nowadays. Alluxio overall, it's data orchestration for the analytics and AI in the cloud. It connects the computing framework with the different distributed storage system, no matter where you want to deal with them. First of all, it help you to increase your data accessibilities, because as we all know, nowadays there are so many big data framework like Presto, Spark, MapReduce, Hive, TensorFlow. And for storage, it also have a bunch of the storage like S3, GC storage, Azure, HDFS, this kind of storage. So it's very hard nowadays to build a comprehensive solution to connect all of them together. So Alluxio here lay at the middle of this kind of framework. So it's easily to help you to connect the computing framework with a different storage system. The second part is nowadays is one very major trend is computing framework. It's not co-located with the storage system anymore. So you always get remote storage system. It will hurt your performance, and it also bring a lot of unknown to you because of the limited network bandwidth or a lot of data transformation through the network. So Alluxio at here helps you to bring the data closer to the computer across silos. So no matter where your data is, it will bring back the data locality to the computing framework. So it will speed the performance up. There are several common use cases in Alluxio. The first one is in the cloud environment. So as we all know, the cloud environment have very inconsistent performance. No matter you get the data from the underlayer cloud storage, or you launch the container VM on their platform, it have a lot of performance variance. At here, Alluxio will help you to provide a consistent I/O throughput to your computing framework to help you to guarantee the SLAs. The second scenario is for the hybrid cloud or hyper data center environment. You can utilize the on-prem compute from data in the cloud. That means when you put the data in the cloud storage, So still can query or get your data from your on-premise data center. For example, you can get the S3 data from the remote in your on-prem Spark cluster. Will help you to enable this kind of scenario. Previously, you will always fetch a lot of meet a lot of problem, especially for the timeout and inconsistent I/O throughput from the remote cloud storage. The third one is allow you to use your data platform and computing framework across the data centers without changing ingesting pipeline across regions. For example, previous what we do is we always ingest data into the two different storage. For example, you want to use the one data center at the East Coast and the one data center at West Coast. You have to ingest the data to the two different data centers at the same time to achieve this kind of goal. Nowadays, you can use Alluxio to manage this kind of scenario without to change your data pipeline. So actually, we have three different key innovations here. We always emphasize that we are not only the catching solution, but we also help you to build a data orchestration that help you to manage your data, no matter where is the data. So the first innovation is we build the unified data lakes. That helps you to support multiple different APIs, especially you want to use S3 API, you want to use HDFS API, and you have a lot of other requests. You can all go through the Alluxio without changing any code there. And for the under layer, you don't need to care about what kind of the storage you are talking to. So Alluxio will automatically handle this kind of request to the under file system for you. The second one is efficient access and easy data management. As many people know that Alluxio help you to accelerate your data, especially when your data is removed. We'll move the data from the remote back to the local and help you to accelerate your computing frameworks and data analytics. And second, we also help you to manage your data. So we have policy-driven data management to help you to move the data from the different storage system to another storage system like this. The third one is we have the environment agnostic and multi-cloud ready functionality. So you don't need to worry about, for example, you have the data in the cloud and you want to query the data from your on-prem data center. You are feel free to do that when you have Alluxio in your system. This is one very simple example journey. For example, you have the on-prem data center with HDFS installed there, and you can build one Alluxio cluster at AWS and another Alluxio system at your data center. So both of them can get the data from the HDFS cluster. And you can very easily to use the different service from the different cloud vendor. For example, here it's AWS EMR. And also you can if you don't want to pay the money for the cloud vendor, you still can use your data center a framework like Hive Spark at your own data center, which will enable a lot of flexibility when you deployment your computing frameworks. Then we will talk about why we want to use Alluxio together with the Iceberg. Nowadays, we know, when you build a big data stack, you are not only using one single component to build your all the software stack. You want to use a different technology to build you the whole system to meet all the different requirements from the different scenarios. For example, Iceberg, if you use Iceberg, you still not have the very good data locality, and you don't have a data management from this kind of service. So based on this kind of reality, people always want to have one kind of Alluxio data orchestration to manage the different data. But first of all, if you build Alluxio into your Iceberg software stack, they will help you to improve the I/O performance and efficiency for data analytics with better data locality. So that means it will guarantee the SLA and also guarantee the performance for your like very critical data analytics. The second one is because we know like Iceberg is a table format. So nowadays we have a concept like manage the metadata, like manage the data. So Alluxio here can help you to manage this kind of files. You can simplify the management of the Iceberg file together with the computer engine. Many times it can take take over part of the metastore management system responsibility and help you to manage all this kind of data. The third one is because nowadays still like lots of distributed system is still like not eventually, is still eventually consistent. So in this kind of scenario, you can mount Alluxio with this kind of under file system. So still can guarantee the transactional data analytics, even you have like eventual consistent file system. So then we will go through how to integrate Alluxio with Iceberg. The first of all, we will give some background on what is the meaning of the strong consistent in the Alluxio world. And we will give two different options for you to build the system with the Iceberg together with Alluxio. First of all, in short, we recommend two different write type when you use Alluxio, because Alluxio is a caching system. So when you write the data back to your UFS, it have 4 different options. If you still want to guarantee the transactional data analytics with the Iceberg, we recommend you use the through and catch through option. That means when the data write back to the UFS under file system, we will return the true to the like computing framework. That means this write is already commit. Otherwise, if you use master cache, it will not write back to the under file system. And if you use the async through, it will write back to the under file system asynchronously. So it will not guarantee the read after write strong consistent in your system. So let's go through the first options when you want to build Alluxio together with Iceberg. This is very simple. When you're able to like mount all your under file system to the Alluxio, so that means all your computing framework is go through Alluxio. You don't need to worry about the consistent issue, because actually Alluxio itself is guaranteed the strong consistent. So when you, for example, the on-prem Spark is here, and another like in the EC2, another Spark is here. When you query to the same Alluxio cluster, actually you don't need to worry about it. You just use any kind of write or read tab when you want to query the Iceberg table, and it will like very support this kind of scenarios very well, and also optimize the performance for your data access. The second option is a little bit comprehensive, because we notice many users not only use Alluxio as their data orchestration layer there, but they still want to write the data directly back to their under file system. For example, here you have the one on-prem Spark cluster that will talk to the Alluxio, but actually another Spark cluster, maybe in the EC2, is talk directly to S3. So in this kind of scenario, when you do the write path, this is what we recommended before. We want to use catch through or through to do this kind of do the write path. That means when you write the data, when Spark write the data back to the Alluxio, at the same time, it will write back the data to the S3. So when all the data is commit, so it will guarantee the consistent for the Iceberg table commit. And when you query the data, it also have 2 different scenarios. When you query the table, you write through the Alluxio, it will be no problem there. But if you query the data from the table that EC2 Spark generated, you always want to get the latest like table for the Iceberg. So that means you want to change the configuration for the metadata sync interval to 0. So you always do the metadata sync, fetch the latest Iceberg table to guarantee you get the latest table from the Iceberg. This is the two different options you can do. And after that, Beinan will give you some real example how we can query Iceberg table with Presto.
Thank you, Shouwei. Yeah, as Shouwei mentioned, I will provide some concrete example about how to use the Iceberg connector in PrestoDB. It's going to be a delay. Okay, so on PrestoDB, there's a connector that can connect or query the tables in Iceberg. I just show you I think it's a starting point, how to use the Iceberg connector. For this one, we can see we are creating a table, creating an Iceberg table in the Presto from a TPCDS table. We are using create table as select. So in this one, we can specify the partition key, and also we can specify what kind of data you need from the TPCDS. By using this query, actually I have seen a lot of our customer and users just by using this query to do something like a data migration. They can copy the data from Hive to Iceberg, or maybe just within Iceberg they can do the migration, something like from HDFS to S3, or maybe they can do S3 to our Alluxio, or they can also use this one to create some temporary table in Alluxio. That's really possible. Some friend maybe ask why we do not use the Spark to do this kind of thing. Yes, we can. We can just use Spark to do the ETL job, to do the data migration. But in this case, our Presto connector might be a little bit faster. Sometimes maybe 2 or 3 times faster than Spark, maybe more. But there's no free lunch. If you're using the Presto Iceberg connector to do your small ETL job, there's no fault tolerance. So if the query failed in the middle, for your ETL job, you should handle the retry on your client side. And also, we should pay more attention about the partition key. If you really want to get a better performance, a good partition key will highly reduce the data we scan. I will cover this kind of thing in the next session. And also in Iceberg, you can do some insert and delete, and the transaction actually is supported in Iceberg. In this example, we just insert one row to the Iceberg table. You can see the Iceberg table actually they provided they call it snapshot level isolation. That means the other user, the other clients cannot see your data, the data you just inserted, but not committed. Something like this one, if it's still running, if it's a huge insertion, if it's still running, the other queryers cannot see the data until you committed the data. And you can see after we insert this data, we can see there's 2 snapshots. We can see the first black block. We can see there's 2 snapshots, and there's a snapshot ID. By using this snapshot ID, we can enable the feature of time traveling. So something like this one, we can just select something from this table. That means you actually select the most up-to-date data in this table. But if you want to select maybe the data yesterday or the data last month, you can just specify a snapshot ID just after your table name. You can see the test 1 is the table name at some snapshot ID. Then you can just go back to the historical data, right? So you can scan do something like a time traveling to select something from maybe the data yesterday. And also, with this Iceberg connector, you can do some thing called schema evolution. So you can change the schema. You can add some new column. Maybe you can also change the type of the columns. In the have connector, if you are doing something like this, if you are changing the schema in a incompatible way, you will see some error from Presto, see some like schema mismatch. But in Iceberg, it's okay if you add new columns or change the type of some old columns. This table is still queryable. Okay. After this short tutorial, I will give some updates from the Presto community. It's a PrestoDB community. The first one is the native folder for the metadata storage. By using this one, we can get rid of a high meta store. I will provide more detail in the next slide. And also we enable the Iceberg local cache. This one can speed up the query in Iceberg connector. The third one is we upgrade the version of the Iceberg and Apache. This from Uber's team, and this one actually it's mostly on PrestoDB side, but it's unblock a lot of new feature from Iceberg. Then on PrestoDB we can enjoy most of the new features of the newest Iceberg version 1.12. This one enabled the Iceberg v2 table. The last one is from me. We implemented the predicted pushdown to Iceberg. It can highly reduce the data we scan on the Iceberg query. Okay, for this one, the Iceberg native catalog is from Jack. He's working for AWS. Actually, we already support we call the Hadoop catalog in Iceberg connector. But for that catalog, or Hive catalog, actually, it's not Hadoop catalog, it's Hive catalog in Iceberg connector. So in this one, it depends on a Hive meta store. So that means for every table, we need to store some entries to some MySQL database or Postgres database. Then the Hive meta store can give us something like a location. Then the Presto know where should I query the data. But you know, I heard a lot of complaint about the Hive meta store, especially for some large scale data set, maybe have more than 10,000 partitions, or maybe for some giant internet companies, they may have more than 10,000 tables. So the Hive meta store might become a bottleneck. And also that one might be a single point failure. If the MySQL behind the Hive meta store is down, that means you cannot query anything in Presto. Right? Error table is missing. So the Jack from AWS, he introduced the Hadoop catalog in PrestoDB. So we call it native catalog. By using this one, we don't need the Hive meta store anymore. We are using a folder, just a normal folder. It can be in S3, can be in HDFS, or just in our Alluxio. Anywhere is okay, just a storage. Then the PrestoDB connector will load all the metadata from that folder to list the table, and we know okay where the table is, and we can query the data. Because you know all of this actually is a distributed file system, so there's no single point failure. Right? We can provide a much higher availability to the Presto and Iceberg connector. This feature called Iceberg local cache. This one is from the Baolong, he's working for Tencent. Actually, the local cache has been in the PrestoDB for a while. This one is highly speed up the Hive query. Actually, we call it Raptor X project in Facebook. They are seeing 10 times faster for the Hive queries. So we just reuse the code. What we did there, we introduce the code to the Iceberg connector. And then that means for the Iceberg query, we can also enjoy the local cache. This one will cache the data in the local SSD. We recommend to use the NVMe SSD to get the better result. But the SATA SSD is also okay, just a little bit slower than the NVMe SSD. And yeah, so this one can, by using the local SSD, that means if the query hit the cache, they don't need to visit the remote storage. It can save a lot of, network bandwidth. It can make your Presto cluster more stable, because we are seeing if we deploy the Presto to some container on cloud or maybe on Kubernetes, we are seeing the higher network traffic may make the maybe make the container got killed or make the container got stop response, something like that. So we can see a lot of failures there. So by using the local cache, we can see the network traffic maybe got at least 60%, and maybe some in some use case 90 or 95% reduced, because it just hit the data in the local. It can provide a better data locality. Yeah, this one is the feature from me actually. We implement the predicate pushdown. Because the Iceberg connector actually asked the Iceberg library to do the plan, do the table scan plan. So we just push down the filter, sample the filter to the table scan node. This is the planning of a query. So if we have two predicates, one is the city, the other is the age, we push down the city to the table scan. You may ask why we do not push down the age, just because the age here is the nested field. I just use this one as an example because some of the field, like the nested field, they cannot push down to the Iceberg. The Iceberg does not accept this kind of predicate like in the nested field, in the subfield. So we keep it, we still keep it, this predicate on Presto side. It's still there. So we can still make the result is accurate, but some of the predicate push down to the table scan. By doing so, we can see I'm still using the TPCDS table I created in the previous slides. We can see before the predicate push down, it scanned 2 million rows. After the predicate push down, it only scanned 1 row, just because I insert just 1 row to the last partition. Right? So at that partition, we only have 1 row. So if we acquire the data there, so it only need to scan 1 partition. It's only 1 row. It can highly reduce the data we scanned. But again, we need to make the partition properly, not too big and not too small, not too many partitions, then it can give a better performance to our Presto queries. And here's some ongoing work. The first one is the native Iceberg IO. It's also from Jack. Because now the PrestoDB is still using the packet and AUX reader from the Hive connector. We reuse a lot of the common code. But if we have some new feature on Iceberg side, that means we should also do the same thing on Presto side. Right? That may have some delay. Right? So if we adopt the native IO, the file reader from Iceberg, that means we can always enjoy the new feature from Iceberg. And the second is the materialized view. It's from Chen in Twitter. So now, because we don't have a materialized view in Iceberg connector, so we are seeing a lot of users. They create a temporary table, maybe in Alluxio, maybe in S3, to cache data because they maybe need some further data processing on the materialized view. So we are thinking to introduce this feature to the Iceberg. So that means it can save you some burden to maintain this kind of temporary table than the materialized view. It's also a table, but it's easier to maintain. You only need to maintain a SQL, right? but the data is there. It's materialized. The last one is the V2 table support. That means we can support row-level insert and deletion. It will make the Iceberg connector more like a OLTP database, just like a MySQL for small data set. Even for some big data set, it's also okay, actually. But for this one, we are still struggling if we make this depends on the native IO or still depends on the Hive connector. I mean, the Presto's packet or ARC reader. So we are still struggling on that. Maybe we need to do the implementation on both. But yeah, that's just something ongoing work we are doing now. Okay, here's the Q&A session. If you have any questions, feel free to ask here.